Alright, in this video I am going to go over how to graph lines using slope-intercept form. We'll start out nice and easy and then we'll ratchet up the difficulty a little bit. Remember, my name is slope-intercept form, and slope-intercept form is given to you in the form y equals m x plus b. In other words, when y is all by itself, the number in front of x is your slope, and the number floating around is the y-intercept. So as we do this problem, what we're going to have to do is understand that I need y all by itself, and I need to find out what my slope and y-intercept is. So this first page is going to be light, not hard. Second page is going to be a little bit worse, but that's all right. Y equals 7 over 2x minus 2. Is this in slope-intercept form? Yes, y is all by itself, which means the number in front of x is 7 over 2. That's my slope. The number floating around all by itself, negative 2, is my y-intercept. I don't know why I didn't put b, but it's too late. Always start out by writing, or drawing rather, a dot where your y-intercept is first. Always start out with your y-intercept. So I'm going to put a dot on the y-axis where negative 2 is. So here's my y-axis. I'm going to put a dot at negative 2. Now I'm going to use the fact that my slope is 7 over 2 to make more dots. So I'm going to go, that's a positive 7 over 2, which means I go up 7 and to the right 2. Up 7 and to the right 2. Up 1, 2, 3, 4, 5, 6, 7, right 1, 2, put a dot. Make as many dots as you can. In this case, I can't go up 7, right 2 again. I can go back to my original dot and try going in the opposite direction, which is down 7, left 2. So 1, 2, 3, 4. Nope, ran out of space again. Once I have as many dots as I can draw out, I connect the dots using a line. And make sure that line covers the entire coordinate plane. Okay. Zoom out a bit. This camera holder's a bit wobbly. I don't like it. Don't like it at all. Whoa! Doesn't help when I bump my desk either. All right, here we are. Is y all by itself? Yes, so the number in front of x is my slope, so my slope is negative 6, but I don't like to view negative 6 as my slope because slope is rise over run, so I'm going to turn it into negative 6 over 1. My slope is negative 6 over 1. My y-intercept is the number floating around all by itself, which is positive 3. I keep screwing that up. b equals positive 3. So I start out by putting my y-intercept on the y-axis. So here's my y-axis. Put a dot at 3 on the y-axis. Dot. Now use that slope to put more dots. A negative slope goes up and to the left. So up 6, left 1. Up 1, 2, 3. Oh, I ran out of room. So I can go down 6, right 1. Down 1, 2, 3, 4, 5, 6, right 1, put a dot. Down 1, 2, 3. Oh, I ran out of room again. Once you have enough dots, you connect them by drawing a perfectly straight line across the entire coordinate plane. Like so. Is y all by itself? But there's no x. Fun fact, y equals just a number is a horizontal line. So I'm going to find -5 on the y-axis, put a dot there, and draw a straight line through -5. That was a fun fact, and an easy one to boot. This guy. Is y all by itself? Yes. The number in front of x is my slope, so my slope is +6/5. The number floating around all by itself is my y-intercept, which is 1. Go to the y-axis and put a dot on that 1. Use that slope to put more dots. So this is a positive slope, so it goes up right, or up 6, right 5. Up 1, 2, 3, 4, 5. Just ran out of room. So instead of going up 6, right 5, I could go down 6, left 5. Down 1, 2, 3, 4, 5, 6. Left 1, 2, 3, 4, 5. Put a dot there. I can't do it again, ran out of room. Once I have as many dots as I have, I'm going to take a ruler and draw a perfectly straight line through those 2 dots, like so. Is y all by itself? It sure is. So the number in front of x is my slope, +1/4. The number floating all by itself is my y-intercept, which is 2. Go to your y-axis and put a dot at that 2. And then use that slope to put as many more dots as you can. Positive slope means up and to the right. So I can go up 1, right 1, 2, 3, 4, put a dot. Up 1, right 1, 2, 3. Oh, I ran out of room. Go to your original dot. And instead of going up and to the right, go down 1 and left 1, 2, 3, 4, put a dot. Go down 1, left 1, 2, 3, 4. Oh, I ran out of room again. Now I have 3 dots. And I can connect them by taking my ruler and drawing a straight line. Now remember this problem up here that said y equals -5? And we said when y equals just a number with no x's, we add a horizontal line? Similarly, if we have x equals just a number, it's going to be a vertical line through that number. That number is 5, so I'm going to go to my x-axis and put a dot on the 5 and draw a nice little vertical line straight up and down, like so. And there you have it. Now those problems are friendly because all of them were solved for y. All of these were solved for y. Well, what if they're not solved for y? What do we do? What do we do? What do we do? Well, it's simple. If they're not solved for y, solve them for y. So I take a look at problem 1 here. And I have 4x plus y equals 0. Is y all by itself? No. What's in the way? Positive 4x is just floating around. How do I get rid of a positive 4x that's just floating around? Minus 4x from both sides. Minus 4x from both sides. Cross it out. Bring down the y. 0 minus 4x is just negative 4x. One of those weird cases where they actually do combine. And that's all I have. Is y all by itself? Yes. So the number in front of x is my slope. So I'm going to say that the slope is negative 4. But instead of negative 4, I want to view it as rise over run. So I'm going to put it as negative 4 over 1. My y-intercept is the number floating by itself. There is no number floating around all by itself, which means the y-intercept is 0. So I go to my y-axis and I find my 0. There it is. Put a dot there, right there at the origin. And if you're looking at that and having, that seems like it's a proportional relationship thoughts, you're thinking correct. My slope is negative 4 over 1, which means up 4, left 1, up 4, left 1. Up 1, 2, 3, 4, left 1, put a dot. Up 1, 2, 3, ran out of space. So I go to my original point and I can go, instead of up and to the left, down and to the right. So down 1, 2, 3, 4, right 1, put a dot. Down 1, 2, oh, ran out of space again. That's all right. I have 3 dots and 3 dots is more than enough. Look at problem 2. Is y all by itself? Not even close. So I have 10x minus 3y equals negative 15. So I've got quite a bit to do to get y all by itself. What's in the way? Well, I have a 10x that's floating around next to it and a negative 3 that's attached. Always get rid of the guy that's floating around first. Minus 10x minus 10x, cross u out. Drop down the negative 3y. Drop down the equals. Does negative 15 and negative 10x combine? No, because this guy has an x and that guy doesn't. I'm going to write out negative 10x first because it's more like slope-intercept form, and then I'm going to write out minus 15, which is the same as negative 15. Is y all by itself now? No. Negative 3 is being multiplied to both sides. So I'm going to divide both sides by negative 3. And when I divide by negative 3, I divide everything by negative 3. So that leaves me with y equals a negative divided by a negative is a positive, and 10 over 3 can't simplify. So I have 10 over 3x. And negative divided by a negative is a positive, and negative 15 divided by 3 is positive 5. That's nice. So is y all by itself now? Sure is. The number in front of x is my slope. So my slope is 10 over 3. And the number floating around all by itself is my y-intercept, so 5 is my y-intercept. So I go to my y-axis, I put a dot on the 5, and positive 10 over 3 is my slope. So I go up 10, right 3. Well, I definitely can't go up 10, but I can go down 10, left 3 probably. Down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Left 1, 2, 3, put a dot. Obviously, those are the only 2 points that I can make. So I'm going to get my ruler. I'm going to draw a line through those 2 points. There you have it. We're going to skip this one because we already did it. And this might be the last one. This will be the last one that we do. Is y all by itself? No. Just a floating x is in the way. No big deal. Just a floating x. How do I get rid of that x that's floating around? Subtract x from both sides. Minus x, cross u out. Drop down the y. y equals, now do these two combine, the negative x and the negative 3? No, because that's x and that's not. So I'm going to write down the negative x first and the minus 3. Now, where is my number in front of x? Well, it's invisible. Invisible negative 1. So my slope is negative 1. But since slope is rise over run, I'm going to write out negative 1 over 1. My y-intercept when y is all by itself is the negative 3 that's just floating around. So b equals negative 3. So I go to my y-axis, I put a dot at negative 3, and my slope is negative 1 over 1. In other words, up 1, left 1, up 1, left 1. So I go up 1, left 1, put a dot, 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 up 1, left 1, put a dot. I ran out of space. I can go down 1, right 1, put a dot, down 1, right 1, put a dot, down 1, right 1, put a dot. Look at all of those dots. So many dots. Could have drawn a better line. Okay. So let's call it quits there. Don't need to make the longest video ever. And that should hopefully make you feel a little bit more comfortable about graphing lines in slope-intercept and not in slope-intercept form. Okay, bye.